Hello, my wonderful viewers. I'm so happy to have you here. If you are just coming across this channel for the first time, you are welcome. And if you are a returning subscriber, thank you for coming back again. We have a very interesting question. Wow, but don't be scared. It's something we can break down bit by bit and then get to the solution. So we have root x as a root of 90. So it's like saying the root x root of 90, the root x root of 60, the root x root of 40. Such an interesting question. So how are we going to start off with solving this question? That's easy. See, I want you to know from one of the laws of indices, if you have a raised by 1 over n, this can be expressed as what? The nth root of what? A. So in the same vein, if I want to express this in this form, using this law of indices, I am going to say 90 raised to the power of what? 1 over root x. The root x is from here. Why this 1 over is from the root already with 90, this root here. Okay? So that is exactly what we're going to do first of all. Now let me just reorganize this thing and begin again. So it's going to be, watch this now, 90 raised to the power of what? 1 over root x, from that law of indices that I showed you earlier. So minus, again here, 60 raised to the power of what? 1 over root x. And this is equal to what? 40 raised to the power of what? 1 over root x. Okay, this is getting simpler as we move on. Now, I have 1 over root x common here, here, and here. Let's make this equation a little simpler. So I'm going to say let m be equal to 1 over root x. By doing that, I would have made the equation simpler. So I'm going to have 90 raised to the power of what? M. No longer 1 over root x. We just said let m be equal to 1 over root x. Then minus 60 raised to the power of what? M is equal to 40 raised to the power of what? M. Such an interesting, simple equation now. So what do? Let me divide through by 40 raised to the power of m. If I do that, I'm going to have 90 raised to the power m over 40 raised to the power m minus 60 raised to the power m over 40 raised to the power m. And this is equal to what? 40 raised to the power m divided by 40 raised to the power m. Is getting interesting. Let me just start here by dividing this. This is already 1. If we come here, what can we do? Now, from one of the laws of indices, if you have a over b, a raised to the power m, b raised to the power m, you can actually rewrite this as a over b because they have a common exponent. I can just use a bracket to group a and b and then assign the common exponent. So I'm going to use this now to reorganize the equation. So I'm going to write 90 over 40, all right, all raised to the power m. See what's happening? Then minus 60 over 40. Do the same thing here. All raised to the power m is equal to, what do we have here? This is just what? 1. So if I simplify this, 0 cancels 0. Same here. And then I'm going to have 9 over 4 raised to the power m minus 6 over 4 all raised to the power m is equal to 1. What can I do with these numbers in the bracket? Let me start with this middle term first. So 2 here is 3 and 2 here is 2. Can you see that? But what about 9 and 4? What is coming to your mind really? Perfect squares. 9 and 4 are perfect squares. So I'm going to express them as a power of 3 and 2 respectively. 9 is going to be 3 raised to the power 2 and 4 is going to be what? 2 raised to the power of 2. And then we still have the exponent of m. So minus what? 3 over 2 raised to the power m is equal to 1. What is coming to your mind already? See, this is 3 over 2 and I have 3 over 2 here. So it looks like we can get something out of these two. I am going to use that formal law of indices that I told you before. Because they have a common exponent of 2, I am now going to group them again as I did earlier. So I'm going to write 3 over 2 all raised to power 2. Then with the exponent of m that was already there, see it here, then minus 3 over 2 raised to power m is equal to what? 1. Okay. So from one of the laws of indices, if you have a over b again, all raised to power, no, let me just make this simple. If you have, say, a raised to power m and then raised to power n, you can switch the position of the exponent. So I can rewrite this as a raised to power n bracket m. Notice if you multiply n and m, you get mn. Same here, if you multiply m and n, you get mn. So nothing has really changed. That's exactly what I'm going to do with the equation above this, with the first term. See, I'm going to reorganize the exponent. So I'll put m here and I'll put 2 right here. Can we do that? Yes, we can. So I'm going to write 3 over 2 raised to power m. The reason why I'm doing that so that it will match perfectly with this right here. It will just match perfectly, and I can even assign it to another variable. You get the drift. So this is going to be what? With the exponent again of what? 2 from here. I just switched the positions of the exponent. Then minus 3 over 2 raised to power m is equal to 1. Is this not beautiful? See what I have here. This is 3 over 2 raised to power m. Same as this, 3 over 2 raised to power m. Can I not just say let 3 over 2 raised to power m be equal to another variable? Yes, I can say that. I can say let n be equal to 3 over 2 raised to power m. Now I'm making it even more simplified. So it's going to be what? N squared minus, this is what? N, and is equal to 1. So we have this simple, beautiful quadratic equation. So this one here, I'm going to move it to the left hand side. So it's going to be what? N squared minus n minus 1 is equal to 0. So I can use the quadratic formula to solve this equation. If you compare it with ax squared minus bx plus bx plus c is equal to 0, you can boldly say that a is the coefficient of the leading term, which is 1, and b is the what? Coefficient of n, which is what? Minus 1, and c is the constant term, which is what? Negative 1. So where's the formula method? It is what? X is equal to minus b plus or minus the square root of what? B squared minus 4ac all over 2a. Now in this case, we're not looking at x, we are looking at what? N. So I'm going to use n. So n will be equal to what? Minus, what's b? B is what? Negative 1. So negative 1 plus or minus the square root of what? B squared. Again, b is what? Negative 1. So negative 1 raised to power 2 minus 4ac. That's 4 times a is 1. And c is what? Negative 1. See it here. Negative 1. Let's extend this radical. All divided by what? 2a. That's 2 times. What is a again? A is 1. And then n is to be equal to, see, minus times negative 1 is 1. And then what's this? This is negative 1 squared. That's going to be what? 1. So what is negative 4 times 1 times negative 4? That's plus 4. So all divided by what? 2 times 1 is 2. Are you with me? So n is equal to 1 plus or minus. What is 1 plus 4? Isn't that 5? Then over 2. It means that I can just say n1 is equal to 1 plus root 5 over 2. And then n2 is equal to what? 1 minus root 5 over 2. Because of plus or minus here. So either plus or minus. Now, remember that n is equal to what? Let's now go bring what n was set to. Let me go back up. See, and let n be what? 3 over 2 raised to power m. We'll put that there. 3 over 2 raised to power m. See this. Now, because if you resolve this, you are going to get a negative sign because what is 1 minus root 5? Root 5 is bigger than 1. So it will give you a negative number. And you cannot put a negative number here because there's an exponent here. If you take the logarithm to both sides, you end up having a logarithm of a negative number, which is undefined. So we're going to reject, we're going to reject n2. So this is what? Rejected. I almost said busted. We're going to reject that, and we're only going to go with what? N1, which is what? 1 plus root 5 over 2. So let's plug it back here. 1 plus root 5 over 2 is equal to 3 over 2 raised by m. Okay, permit me to take this, to start with this 3 over 2 raised by m. It's same thing, 1 plus what? Root 5 over 2. Since I need to get the value of m, I am going to take the logarithm to both sides. Let me say that again. I will take the logarithm to both sides. Okay, so log 3 over 2 raised by m is equal to what? Log 1 plus root 5 over 2. So from one of the laws of logarithm, this exponent will be made to multiply the what? Logarithm. So I'm going to have m log 3 over 2 is equal to what? Log 1 plus root 5 over 2. So I'm going to divide both sides by what? The coefficient of m, this right here. So I will divide both sides by what? Log 3 over 2. So m will be equal to what? Log 1 plus root 5 over 2, okay, over what? Log 3 over 2. I think this is the end of the road for m. We know what m was set to, right? Let's go back. I say recall that m is equal to, let's go back up. See, let's say let m be equal to what? 1 over root x. So we'll plug it back into the equation, 1 over root x. Recall that m is equal to 1 over root x. I'll plug it back in here, and then we get the value of x, our long-awaited x. So that's log what? 1 plus root 5 over 2 divided by what? Log what? 3 over 2. So what I'm going to do is that I'm going to flip this. I'm going to take the reciprocal of this, and I will do the same thing with this as well. So it's like turning it upside down. So I'll have root x over 1, or just root x is equal to what? Log 3 over 2, I'm flipping it, over what? Log 1 plus root 5 over 2. Oh, sorry. That 2 is almost visible. But you get the idea. So I have root x is equal to, now from one of the laws of logarithm, if you have log a over b, that's the division law, this will be equal to what? Log a minus log b. This rule of logarithm will be applied to the numerator and what? The denominator. So that's going to be what? Log 3 minus log 2, because of this division here. Let me show you. There's a division here, right? Good. Then all divided by what? Log 1 plus root 5. Again, there's another division. Then minus log what? 2. Okay, so I'm going to use my calculator and get the logarithm of 3. I'll just be fast about this. Log 3 is 0.4771 and log 2 is 0.3010. All divided by what? So real quick, log 1 plus root 5 is equal to what? 0.5100 minus, what is log 2? Again, 0.3010. Okay, let's simplify this further. So root x will be equal to, if you take the difference of these two numbers, I'm going to have what? 0.1761 divided by what? If you take the difference again of these two numbers, you are going to get what? 0.209. It's time for us to divide these two numbers. So root x will be equal to what? You divide that, we are going to get 0.8426. And we're almost done. To get rid of the square root here, I will square both sides. So square cancel square root, and you have that x is equal to the square of 0.8426, which is what? 0.71. And this has been rounded off to what? 2 decimal places. I hope you enjoyed this video. If you did, kindly like this video, share it with your friends and family, and don't forget to subscribe to this channel. I upload videos on this channel on a regular basis, and I don't want you to miss any of them. I will see you in the next video, and it's bye for now.